Okay, we're going to start into triangles today. All right. The interior angle theorem, basically, we've known this for a long time, that three angles add up to 180 degrees, right? Okay. So on these three, you would add these two together and subtract from 180 to get x. Okay, so that's 101 minus 180, and so that would be 79 for this one. Okay, so angle B is going to be 79 degrees, and I don't know why they put these on there. Obviously, A is 59 and 42 for C. And if you added these up, you would get 180. Okay, so these three add up to 180, right? So you can make an equation. You can say x plus 2x plus 3x is equal to 180. And then 1, 2, and 3, that's 6x. 6x equals 180, divide by 6, and you will get x is equal to 30. Okay, so this is 30 degrees. Okay, if you plug a 30 in here, you'll get 60, right? And a 30 in here, and you'll get 90. Okay, so B is 90 degrees, C is 30 degrees, and A is 60 degrees. Okay, it's actually a right triangle. Okay, this one has three different angles, so you would say 3x plus 10 plus x minus 8 plus 34 is equal to 180. Okay, so 3x and x is 4x. 10 and 34 is 44, minus 8 is 36. Okay, so it's a plus 36 is equal to 180. So you would subtract 36 from both sides, and you would get 4x equals to 144. So if you divided that, you would get, what is that? 4, 12, and 6, 18. Yeah, 18. Divide by 4, you get 18. So x is equal to 18. Okay, if you plug, you know that C is 34. 18 in here, that'd be 54 plus 10 is 64 for A. And then 18 in here, minus 8. That's pretty small. Okay, 18 minus 8 is 10. Anyway, these are not drawn to scale. Okay, so the exterior angle theorem is when you have an exterior angle on the outside, and these are two remote interior angles. Okay, basically this one plus this one adds up to be this one on the outside. Okay, if this was, say, 60 and this was 50, then this would be 110. Okay, now when they say remote interior angles, okay, there's three angles in a triangle, right? Okay, remote would be very far away, like you have a remote, so you don't have to be next to the TV, right? So these are the two furthest away from this angle over here. So these two always add up to be this guy, okay? So measure of 1 is equal to measure of 2 plus 3, okay? So this one, if you wanted to find angle 3, okay? If you wanted to find angle 3 here, and you had the outside one and one of the inside ones, yeah, you just subtract, right? 125 minus 60 will be 65 for this one. And you can tell that this plus this is equal to 125. So that's 65 degrees. Okay, this one's always looks complicated. All right, so angle 1, if you think about it, that right there is this one upside down, right? So that's the exterior angle, like we called it up here, an exterior angle, and these are the two remote interior angles. So if you add those two up, you'd get 128, and that would be angle 1. So angle 1 is 128 degrees. Angle 2, this is a straight line, right? So if it's a straight line, it's like 180, right? So you'd have this. So if you know this is 128, and you wanted to find this one, angle 2, you'd have to say 180 minus 128, right? Or, yeah, 180 minus 128 is going to be 52. So that's 52, okay? And this one's 120. This is actually another, I probably need another color pen or something. I didn't bring enough. Okay, this one is the same as this pink one and this one over here. Basically, that's the exterior angle for these two remote interior angles over here. So 120 minus the 52 will get you 48 and 20, 68. So that's 68 degrees here for angle 3. So angle 2 was 52, angle 3 was 68. And we know what angle 4 is, right? That's a straight line. It's just an upside down linear pair, right? So 180 minus 120 is, of course, 60, right? So angle 4 is 60. And then, once again, wish I had another color pen, but I don't. I'll just use this one. This is the exterior angle for these two remote interior angles. So it's an upside down exterior angle like this, right? With angle 5 being the exterior angle. So these two add up to be this one, which is 116. Okay. So angle 4 was 60 and angle 5 was 116. Okay. All right. Here's an exterior angle, but now we've got just more complicated stuff. But basically, we know that the two remote interior angles add up to be the 110, right? So just write it up. 3x plus 5 plus 2x equals to 110. So you combine the like terms. That's 5x plus 5 is equal to 110. Subtract 5, right? And you get 5x is equal to 105. If you divide by 5, you get 21. Okay, so all they asked for was x this time. All right, same here. This one plus this one. If you add those together, you can set it equal to this. So you can say x plus 70 is equal to 2x minus 5. And we just have an x on both sides. Do you remember what we do when we have an x on both sides? Yeah, you get rid of the smallest x, right? Okay, so can y'all see? Hopefully y'all been able to see good. Okay, so that's gone. So you got 70 is equal to x minus 5. Add 5 to both sides, and x is equal to 75. Okay? All right, next page. That had to do with angles. Okay, this has to do with what's called a Pythagorean triple, which means all three numbers in a right triangle are whole numbers. Okay? So they need to be whole numbers. Okay? So you remember how I told you to find this one, right? Okay, it's kind of like finding the distance on a graph. This is a squared and b squared, doesn't matter which order. So you do the square root of 12 squared plus 5 squared, take the square root of it, and you'd get an answer for this one, okay? And I know what it is, but I'll show you on the calculator. It's 13. Anyway, so you go second, square root, make sure y'all can see, all right? And then 12 squared plus 5 squared is equal to that, so that's 13. Okay, since all of them are whole numbers, then it's a Pythagorean triple. You would say, yes, it's a Pythagorean triple, okay? This one has a 12 and this is an x, but they gave us the hypotenuse. Now, we haven't really talked about this much, but this is what I call the adding Pythagorean theorem whenever you have the two short sides. But whenever you have one of the long sides, then we use the subtracting Pythagorean theorem, right? Where we would say the hypotenuse, the c squared, and you would subtract whatever one that you don't have. So, like you would do I'll just call it a squared. Okay, so basically you're doing this. You're saying 15 squared, you always put it first, that's the hypotenuse, and then you subtract the one that you have, the 12 squared, and you see if it's a whole number, okay? So, second square root 15 squared minus 12 squared, and it's 9. Yay! So this is a Pythagorean triple as well. Yes. Okay. So let's go over here and see if this one is. Okay. This is the subtracting kind, right? Because you have the hypotenuse. So you say 17 squared minus 12 squared. Okay. So we punch it in. So it didn't work out. Okay. So this is not Pythagorean triple, let's say PT. Okay, so we want to know if this is a right triangle. If it's a right triangle, then it's got to have a 90 here, doesn't it? Okay, how do we know if two lines are 90s to each other on graphs? Okay, well, basically the idea is that you find the slopes and you see if they're negative reciprocals of each other. Remember how we did that? Like if we had -3/2 for a slope, and then we then we flipped it over. You know, you have to have a 90 here, okay? You flipped it over and changed the sign, right? So we're going to see what the slope is of this one and see if they're negative reciprocals. Now, I don't know if that's what this was going to be. I don't really know. Okay, so the slope of this line, okay, anyway, so I showed y'all Desmos, but you do y2 minus y1 over x2 minus x1, okay? So y2, this is the second y, so we'll just say this is x2, y2, and this is x1, y1, okay? So now we subtract the y's on top. 0 minus 2, well, we'll just do it here. That's PO, yeah, 0 minus 2 over 0 minus a negative 1. 0 minus a negative 1. Remember that was plus? So I'm going to change that to a plus. So this is negative 2 over 1, right? Or just negative 2 is the slope. Okay, makes sense. It's downhill. Down 2 and over 1 is what it is, really. Okay, so now the slope of this one is, okay, I'm going to say that this is the x2, y2, and we'll call this x1, y1 now. Okay, so we subtract the y's backwards. 3 minus 0 over 6 minus 0, and that's 1/2, right? So are these negative reciprocals? Yes. Okay, negative 2 over 1, if you flip it and change the sign, is 1/2. Okay, so that means that this is a 90, and this is a right triangle. Okay, right triangle. And then you can use the distance formula to find each one of these three to see if they're scalene or not. Okay, I would prefer to do it this way, where I go like this. Okay, that's down. So that's a 1, 2, right? So I do 1 squared plus 2 squared. Okay, this one is that's 3 up, right? And then 6 this way. Okay, so that's a 3, 6. So I do square root of 3 squared plus 6 squared, and then OQ. I'm putting them in the wrong place, I think. Oh well, whatever. I'm gonna do this, I'll change these in a minute. Okay, so this one right here is, if I made a right triangle this way, that's a 1, and that would be 6. So 1, 6, and it'd be 1 squared plus 6 squared. Okay, so we're basically wanting to know how long each one is to see if it's scalene, all sides different. Okay, so clear square root of 1 squared plus 2 squared, that's 2.2. Okay, the second radical, 3 squared plus 6 squared is 6.7. And then second radical, 1 squared plus 6 squared is 6.08 or 6.1. So they're all three different sizes, so it's a scalene right triangle. Okay, a scalene right triangle. All right, these are the kind, like I was talking about before, where you see if it's a Pythagorean triple. They just give you the three numbers. Okay, a 5, 12, 13. Okay, you can do it this way. You can say 5 squared plus 12 squared is equal to 13 squared, and it should be equal on both sides when you get done. 5 squared is 25, that's 144, and that's 169. These two add up to 169, so if it's equal on both sides, yay, it's a Pythagorean triple. Okay, so yes it is. Okay, this one over here, a 4, 6, 8, you'd say 4 squared plus 6 squared is equal to 8 squared. Okay, you take that's, what is that, 16 plus 36, and that's 64, and this is 52 when you add it. So since they're not equal, it's not a Pythagorean triple. Okay, this one's a P2 and this one's not P2. Okay, all right, this is isosceles, so that means that, and it says DI is congruent to IS, right? So I'm going to put those on there. That also means that this angle and this angle are congruent, right? We talked about isosceles before. Basically, these are congruent and the base angles are congruent as well. This is called the vertex angle, okay? That's the vertex angle, right? Okay, so the vertex angle is angle I. Okay, if DI, let me use pencil because I'm not going to erase. Okay, it's 7. Can y'all see? Oh God. Okay, I'm going back. Okay, this one and this one are congruent, so the base angles are congruent, right? And this one is the vertex angle, okay? The one that is between the two legs that are congruent, okay? So angle I is the vertex angle. Then I said that DI is 7, so what's this one? IS, well, that has to be 7 as well, right? So we put 7 there. Okay, angle D is 70, then what's angle S? Well, it's got to be 70 as well, right? Because they're both the same. And then if D is 80, okay, let me erase. If D is 80, then they want to know what this one is. So I'd have to go ahead and fill in an 80 here. And 80 and 80 is 160, and you subtract from 180, and you get 20 for this guy. So that's true, okay? Now if I, up top, is 100, okay, then how do you find these two? Because you know they're equal. So 180 minus the 100 is 80, right? So if you take 80 and divide by 2, you get 40 and 40. Okay, so they asked for D and S, so that's 40 and 40, okay? If DI is congruent to IS, if this one's congruent to this one, then D is congruent to S, right? Angle D is congruent to S, right? So if these legs are congruent, then the base angles are congruent. Now I'm going to say it backwards. If the base angles are congruent, D and S, then we know that DI is congruent to IS. Okay? And then this last one, we're not going to worry about it. I meant to knock that off before. Okay, last part. Okay, so equilateral, if these are all congruent, equilateral means equal sides, then all the angles are also congruent. And we know that since they're congruent, 180 for all three of them, divide by 3, and you get 60, 60, and 60, right? So that's what it's showing here, okay? So if it's equilateral, it's equiangular. If it's equiangular, it's equilateral. All the sides are congruent, all the angles are congruent, okay? Now, this says this is equilateral, so I got this, okay? And then they give us all this stuff here, like this is x plus 9, and ag is 2x, and this is 3x minus 9. Now, the typical mistake is to say this one plus this one plus this one equals 180. But we're not talking about angles, right? We're talking about sides. So all you have to do is pick 2 of them that are congruent, and whenever they're congruent, you set them equal to each other, right? So I'm going to say x plus 9 is equal to 2x, okay? I could have picked any one of them, and it would have worked. Okay, x on both sides, so I get rid of the smallest x, right? And then I've got 9 is equal to x. So 9 is x. If I want to know J-A, then I plug 9 in there, and you get 18, right? If you put a 9 there. Okay, this one, if you put 9, you get, oh, guess what? 18. And then this better be 18, right? Since it's equilateral. Okay, 9 times, or 3 is 27, minus 9 is, guess what? 18. Okay? So you see how to do it? You pick 2 of them, set them equal, and solve, plug back in. Okay, this is isosceles, right? That means that 2 of them are congruent. So they tell us that EF is 4x, FG, 2x plus 6, and EG is 14, right? Now this is a distractor, okay? Nobody needs 14. You just need to set these equal to each other, right? Okay, if they wanted a perimeter, we'd have to use that later or something, but not at this point.
Bye, Johnny. I'll see you tomorrow.
Yeah, see you later.
Okay.
So you set those equal to each other. 4x is equal to 2x plus 6. Okay, you subtract 2x from both sides. And then 2x is equal to 6, and then you divide by 2, and x is equal to 3. Okay, so x is 3. EF is this one, so you plug a 3 in there, and that's 12. FG should also be 12, right? So 2 times 3 is 6, plus 6 is 12 as well. Okay, so that's it. Anyway, have a good day.